we're looking at function graph. Function graph. Now, under function graph, we have to know three things. Number one, we have to know how to fill values on the graph. Number two, we have to know how to draw the graph itself. And number three, we have to know how to answer questions after drawing the graph. Now, let's look at this example clearly. We are given function of x is equal to x squared plus x minus 6. Now, using this function, we can fill all the values here. For example, minus 3, we shall substitute on the place of x and on the place of x. Then when we solve, we get 0. In the same way, we shall substitute minus 2 on the places of x and we get negative 4. And we shall continue until we get all the values. Now, after getting all the values and we are given a grid table, we shall plot all these points. Negative 4 and 6, we shall plot negative 4 and 6, our point will come there. Then we shall plot negative 3 and 0, negative 3 and 0, negative 2 and 4, we shall plot. And after plotting all the points on exact positions where they should go, then we shall get our pencil and we shall join the points with a very smooth curve. This will be our graph. Now, we have the points on the table and we have already drawn the graph. What is next? How do we answer questions? Now, let's start from C. Roman 1. Fx is equal to t has one solution. Then we are supposed to find the value of t. On the same case, fx is equal to k has two solutions. Then we are supposed to find the value of k. And fx is equal to m has no solution. Remember, for any function is always equal to y. Therefore, all these letters t, k, m, they are all representing the y values. So when we go back to our graph, we shall see that these are our y values. As you can see, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, and so on. All those are our y values. Therefore, when you look at t, we shall get the answer from the y-axis. Now, when does our graph have one solution? Remember, when we have our graph and when we have that position, the turning point, that's exactly where we shall have one solution. And the position of the y-axis, which gives us one solution, is negative 6.4. We shall get negative 6.4. So at that value of t, we shall have exactly one solution from our curve. Then fx is equal to k has two solutions. What value of k has two solutions? Let's go back to our graph. Now, at this point, we have one solution. Remember, any value of y-axis above will give us two solutions. If I am standing at negative 6, I have one solution here, another solution there. If I am standing at negative 4, I have one solution there, another solution here. If I am standing at negative 2, I have two. So we shall conclude that all values above will give us two solutions. At the same point, all values below, we shall have no solution. Why? Because our curve is turning upwards. Meaning what? We don't have the graph below. So all the value below negative 4, negative 6.4 will have no solution. Hence, all values above negative 6.4 have two solutions, and all values below negative 6.4 have no solution. So when you come here, K has two solutions. The value of K will be any value which is greater than negative 6.4. At the same time, M has no solution, will be all the values which are smaller than negative 6.4. Let's look at another example. Here, we are told find the values of x when the curve has negative gradient. Now, when does a curve have negative gradient? Here we have an example. If our curve is turning upwards, at the turning point we have no gradient. This means from the left side, if the graph is going down, meaning negative gradient, and if the graph is going up, it means positive gradient. On the same note, if the graph is turning down, meaning what? On this left side, it's going up. If it's going up, it means positive gradient, and if it's going down, it means negative gradient. Even here, when the cubic graph, we can see going up, going down, going up. When it's going up, positive gradient. When it's going down, negative gradient. When it's going up again, positive gradient. Now, when we look at our graph starts from left going down, meaning what? Meaning this side, our graph is negative. And after the turning point, our graph is going up. It means positive gradient, meaning what? The value at the turning point is negative 0.5. So all the values of x which are smaller than negative 0.5 will give us negative gradient. And all the values of x which are greater than negative 0.5 will give us positive gradient. Hence, x is less than negative 0.5, giving us negative gradient. And at the same time, positive gradient will be x being bigger than negative 0.5. Now, we have our function. Remember, the value inside the bracket is x value. So, in order for us to use the graph to solve this function, we shall go to our graph, and on the place where there is 2, we shall look at it from the x-axis. So we shall go at x-axis 2, and we shall realize that here our value of y is 0. Hence, when we have x2, the y reading on the graph will be 0. Now, when you look at the next example, x is not given, but we are given y. So we shall go to y value of 6. When we come to y reading of 6, we shall have one solution here, that is 3, and also we shall have another solution here, that is negative 4. Hence, when y is 6, we shall have two solutions, negative 4 and 3. So we shall have negative 4 and 3. Now, when we are told it is the inverse of this function, the value inside the bracket, which was formerly x reading, because of the inverse factor, this value we shall take it as y reading. And the value at y, because of the inverse factor, we shall take it as x reading on our graph. So here, I will go to y reading and I will read negative 4. Here, that is negative 4. I will have two solutions, here and there. This will be negative 2, and the second solution will be 1. So I will have negative 2 and 1. On the same point, on the next example, I will have 1 as x. So I will go to 1 as x, then I will go down till the curve, and I'll get the y reading as negative 4. Hence, my answer will be negative 4. F. By drawing a tangent at x is negative 2, find the gradient of the curve. This means, first we have to draw the tangent at negative 2. So we shall go to the graph. Negative 2 is here. Then where is my curve? My curve is touching there. So at that point where my curve is touching, I have to put my ruler properly and I draw a tangent. A tangent is a straight line that touches the curve. Then after drawing the tangent, I will get 2 points on the curve, on the tangent. 1 point, I will take this point because it is touching the tangent, -2 and -4. Then I will take another point on the tangent. I will take this point, that is x is 0 and y is -9. So I will have -2 and -4, 0 and -9. Then after getting the 2 points from the tangent, I will go ahead to use the normal formula for finding the gradient. That is y2 minus y1 over x2 minus x1. I will take this as my x1, y1, x2, y2. So I will write y2 minus y1, x2 minus x1. And finally, my answer will be -2.5 as our final gradient. That's how we find gradient using tangent information. So another question could be, on the same grid, draw another graph. Now, if we are drawing another graph, meaning we have to create a small table values, but we have to use x readings that are existing on our graph. So if I take any value, could be -1 and +1, I substitute here -1 plus -4, I get -5. Then 1 minus 4, I get -3. I will plot these 2 points here. -1 and -5, 1 and -3. Then I'll get my ruler and I will draw a straight line like that, and I will name my graph. So this will be the line which is asked for there. H. Use the graph of fx and the graph of gx to solve. Remember, our graph of fx is this one, the curve which we drew earlier. That's our fx. And our gx is the straight line which we have just drawn. Remember, these two are meeting here and there. Where the two graphs are meeting, that is where these two graphs are equal. So these two graphs are equal at -1.4, and also they are equal at 1.5. So when the two graphs are equal, it will be -1.4 and +1.5. Next, when fx is less than gx, remember, the graph is less than the other only when that graph is below the other graph. So I will go and I check. My fx graph is below gx here. So at this position, when fx is below gx, that is when fx is smaller. Meaning what? All the values which are making this fx small are between -1.4 and 1.5. And we shall state our answer as -1.4 is less than x, x is less than 1.5. Finally, fx is greater than gx. This means fx is on top of gx. Now, when we look at our graph, fx is on top on this side because this side fx is up, gx is down. And also, fx is up this side and gx is down, meaning that we shall have two solutions. Our value of x will be smaller than -1.4 as one solution, and the other solution, our value of x will be greater than 1.5 as stated here. One answer will be x is smaller than negative 1.4, and the other solution, x will be greater than 1.5. So this is our summary of function graph questions. Remember, number 1, we have to fill the table of values. 2, we have to draw the graph itself. And 3, we have to answer so many questions using the graphs we have drawn. Thank you for watching. My name is Mr. Ishengoma.